Welcome to qnawire.
Okay, so in this scenario, you have a block or a bullet in this case that is launched at a speed v into a pendulum that is attached with a massless rigid rod of length L. And after this system collides, you are told that the bullet still is still moving to the right at a velocity v over 2. And then this pendulum here, in this case, let's say swings up through this rod here, swings up to a vertical orientation. And that is the collision. So um, this set up a problem, and now you want to see how you can solve it. But the first thing is first, we always have to write in our equations for conservation of momentum, because momentum is always conserved every time you have a collision. So in this case, the initial momentum is actually just the bullet, because it's the only mass that's moving. So this has mass m, say, and then this has mass m, and then the rod is masses, of course. So you have the mass times velocity of the bullet should be equal to the mass times velocity over 2, because this thing is now moving with half the velocity because you went through the block. Plus, now you have the velocity of the block as well, because as soon as this collision happens, this thing is going to start to swing from a certain height here. So it's going to swing through the center of the circle here with some speed, big V, to get to the top here. So we're going to say that the momentum of that system is now m times big V right there. So this will constitute your conservation momentum equation, which we can now simplify. Notice that this term is common for both sides, so we can just go ahead and subtract that, and we'll see that what you are left with over here is just half mv is equal to m plus big V. So we can go ahead and just say mv over 2 is equal to m big V in this case. And you'll notice that now we can go ahead and just write that the velocity, this initial velocity of the bullet here, is actually 2 big M big V over small m. Right, so we'll keep note of this expression here. So now we want to take into account what happens to this big V here. So the only way you can get through this vertical circle here is if you have enough velocity to take you to the top. And the minimum amount of velocity that you need to take you to the top is the amount of velocity that will give you enough kinetic energy to gain all the potential energy that you need to get to this point. So essentially, when you're at the top, you have potential energy, and you're at the bottom here, all you have is kinetic energy. So we're going to use, again, energy equations to solve this problem. So we can say that the kinetic energy right after this collision was half m times this big V squared. That should be equal to the total amount of potential energy that you're going to have once you get to the top. And once you get to the top, remember, this is swinging through the center, and this rod is length L, which means the height change is actually 2L. So this is going to be equal to mass times gravity, again, times 2L, which is the length of the rod. So we can go ahead and cancel the masses here, and we can find that V squared is actually equal to, again, 4GL. Right, so now we know that big V is actually just equal to 2 square root of GL. So once you now have this expression for big V, you can just substitute in here because you're not given big V in the problem. So the final result is going to say that small v is actually equal to, again, 2 by 2m here. So that will give you 4 big M square root of GL over the smaller mass of the bullet.